Today we're going to be looking at solving systems of equations. All right, there are two standards that are involved with this lesson. And your success criteria: describe what a nonlinear system of equations is. So be able to describe what a system is. Solve systems using graphing, substitution, or elimination. And solve quadratic equations by graphing each side of the equation. You've got one vocabulary term. Make sure you have this in your notes. A system of nonlinear equations is a system in which at least one of the equations is nonlinear. Remember, linear is an equation of a line, so nonlinear would be an equation of something other than a line. All right, example 1 is solving a linear system. So this is a quick reminder from Algebra 1. So to solve this system, you can either do substitution, elimination, graphing. There's several ways you can do that. So let's pull up our calculator and graph this system quickly. All right, so if we have a system of equations, we're just going to graph both lines, and then we're going to find the intersection point. So I've got negative 2x plus 4, and then arrow down, and I need 3x minus 1. Now, let's see. Got an error. Oh, I put... Okay, so there's a minus sign and there's a negative sign, and the calculator's kind of picky about which one. This should be a negative 2x, so I'll just put the wrong negative in there. All right, so there's the first line. There's the second line. You can see both of these are linears. They're both equations of lines, and this intersection point is the solution. So I need to solve it by finding the intersection point. 5 is the intersection point. I'm going to hit enter on the left side, and then I'm going to hit enter on the right side, and then it says the intersection is 1, 2. So the intersection is 1, 2. All right, so that's my x and my y value, so I can check this by simply plugging that in. So if my y is 2, I can say does 2 equal negative 2 times x? X is 1 in this case, plus 4. All right, does 2 equal negative 2 plus 4? Negative 2 plus 4 is 2, so that works. So I know that works in the first equation. To be a solution of the system, it has to be a solution to both equations. So I've got to check the second equation as well. So I'm going to say, does 2 equal 3 times 1 minus 1? So again, just substituting my x and y into the second equation. All right, so does 2 equal 3? 3 minus 1 is 2. That one works as well. So because this is a solution to both equations in the system, it is a solution to the system. All right, if you choose to do substitution, because both of these are set equal to y, you could simply set the two equations equal and solve for x, and then plug your x back in to find y. So you could do that as well. All right, the second one here. Solve the system. 2x plus 3y equals 7, and 3x minus y equals 5. So the first thing we need to do for this one is to get each equation, if we're going to put it in the calculator, we got to solve for y. So let's say 2x plus 3y equals 7. So we're trying to solve for y here. Means we want y by itself, so we're going to subtract 2x from both sides. So we're going to have 3y equals negative 2x plus 7, and then divide by 3. And when I say divide by 3, you're going to divide the entire equation by 3. All right, so that's our first equation in slope-intercept form, meaning that's the way we need it to put it in the calculator and graph it. And we've got 3x minus y equals 5. This time it'd be easier to move the y over. So let's move the y over. So I've got 3x equals y plus 5, and then subtract 5. So y equals 3x minus 5. So now this one's in slope-intercept form as well. And then we can do the same thing, use our calculator to find the intersection point. All right, so if I go to y equals and I hit clear, and I hit clear, I need to put my graphs in here. So I've got, make sure I use a negative sign this time. So I'm going to use negative 2/3 x. And then plus 7/3. And then I've got 3x minus 5. And then hit graph. All right, so you can see it's right in here. It looks like 2, 1, but let's check it. So second, trace, and number 5 is intersect. I want to click on it on the left side, and again on the right side. And it gives us our solution of 2, 1. So the solution to this one is 2, 1. You should also take and plug that into your x and y and check it. You can quickly do that. 2 times 2 is 4. 4 plus 3 is 7. So it works for the first one. 3 times 2 is 6. 6 minus 1 is 5. So you can quickly check that and know that that is, in fact, your solution. Solving a nonlinear system by graphing. All right, so x squared minus 2x minus 1, we've just been working with quadratic equations, so we know that this is a quadratic equation, so it's shaped like a parabola. And then this one, of course, is linear because it's x to the first power. So you're going to have 3 possible types of solutions. So you can have no real solution if they don't intersect at all. If the line intersects the parabola at one point, you're going to have 1 real solution. And if the line goes through the parabola at 2 points, you will have 2 real solutions. All right, so it says solve by graphing, so we're going to pull up our calculator again. All right, we're going to do y equals x squared minus 2x. And you can graph these without a calculator if you want. That's very possible. We've been graphing quadratics in the last few sections, and we graphed linear equations earlier, but since we're looking for the intersection point, when you draw a graph, sometimes I know when I draw a graph, my lines are not as straight as the computer. So I feel like if I do it on the calculator, my lines are going to be much straighter, meaning my answer is going to be more exact. All right, so this appears that it's going to cross right here. I can't tell if it crosses once or twice, but let's do second trace. Let's do intersect. And let's go to the left of it and to the right of it. If there's only 1 point, it should give us a solution. If there's more than one, it would give us an error. Okay, so this is negative 2.009e to the negative 7. So this is the calculator's way of saying scientific notation, which means this decimal would be moved over 7 places. And so it would be like negative 0.0000, 6 zeros, then the 2. So this is basically can be rounded to 0. And if you look here, it's on the y-axis, so that makes sense that your x is close to 0. So x is 0, and y looks like it's close to negative 1. So we're going to say 0, negative 1. And then we can plug that in to see if that is a solution. So we can say 0, negative 1. You also can go to your table of values if you want to check your table of values and see 0, -1 falls on both of those graphs. So 0, -1 would be the solution. But still, let's check it. So we're going to put -1 in for y equals 0 squared minus 2 times 0 minus 1. 0 squared is 0, minus 2 times 0 is 0. So -1 equals -1. That is a true statement. All right, let's check the second equation, because again, a solution has to be a solution to both equations, not just one. So we're going to have -1 equals -2 times 0 minus 1. Again, -1 equals -1. That one works as well. So we know this is the one and only solution to this system. That would be like the middle answer here, where there is one solution. The line intersects the parabola at one place. All right, I'm hoping you have your own graphing calculator and have time to do the self-assessment. This is Solve the System by Graphing. I want you to practice this, because the more practice you get using your graphing calculator, the better you're going to be when it comes to test time, standardized test time, and even using your calculator on the ACT. ACT is a timed test, 60 questions in 60 minutes. For the math part, it's important that you know how to use your calculator as quickly as possible, but also accurately. So take a minute, pause the video, and try to do the self-assessment and solve the system by graphing. All right, for the self-assessment, hopefully you took time to graph these. If you look on here, it looks like about 0, -2, and 1, 2, 3, 4, 5, up, maybe 3. So let's say 0, -2, and 5, 3. So let's look at the table of values and see if they have the same y values. 0, -2 is a solution. They have the same y value. And 5, 3 is also a solution. So you can determine that from the table of values. You can also plug these back in and check them. 0, -2, and 5, 3. All right, and again, you can kind of estimate those looking at the graph. You can also do second trace and find the intersection points of both of those. But hopefully you got 0, -2, 5, 3. You checked them, and you can see that this one has 2 solutions. So it's 2 real solutions, and that would be the answer for the system.